Okay, there we go. All right. So, anyways, so let's read the webpage as shown below. Sophia, and Zara are doing an investigation to see how mass affects floating and sinking. They have a glass container of water. Okay, the container is made of glass. Now they made a raft out of a square piece of flat polyester, which is a form of plastic. Polyester is plastic. Okay, just know that it's just a really advanced way to say plastic. That's what polyester is. Okay, good. Now, all right. Now, let's try putting some coins on the raft and see how many we put on before the raft sinks, said Zara. And they put a pile of different coins on the table. You have to use the same side coins and sort them out. And then Zara puts a coin in the balance. Each coin has a mass of 5 grams. So, can anybody tell me the control variable of this experiment? The control variable is the thing that doesn't change, okay? Anyone? Control is the variable that didn't change, all right?
The glass container of water and the coins
The glass must have water, yes. And the
and the
coins must be the same size and has to be the same mass, all right?
yes.
Because if you have a different size or a different mass, you have a different density. And the different density means, yeah, you won't get the same experiments. Now, can anybody tell me what is the independent variable, which is the variable that you change? All right, the dependent variable is the one that gets affected. The independent variable is the one that changes. So, what is the independent variable?
The amount of coins in the raft.
Mm-hmm. Yeah. So the control is well. Oh no, sorry. The independent variable is basically the how many coins you put on the rafts. And the dependent variable is whether the raft sinks or not. If the raft sinks, then that means you have put in enough coins for it to sink. Now, can anybody explain to me why did the polyester raft float on the water? Remember, polyester is plastic. So why did it
Because plastic because plastics float on water.
Yeah, most plastics you would assume would float on water. Polyester is an example of them because they have a lower density than water. If you try holding a plastic bag, you know that it's way lighter than, say, I don't know, you piece of steel, right? Because they have a way lower density. Now, can anybody tell me when the girls put the 7 coins on the raft? It's after that if you, they put after they put 7 coins, it sank. Now, why did the raft sink? Can anybody tell me why did the raft sink?
Because
Anyone?
its mass is heavier than the mass of the water that the container. If they put 7 coins, the total mass of the coins is 35 grams. And I think that it might large if the mass this time is larger than the mass of the water in the container. So maybe it's
All right. So, when we put enough coins onto the raft, it it suddenly becomes unable to float because the density becomes too high. If you take and basically it technically becomes too heavy, so it can't float. Again, remember, floating or sinking is measured by the density and not the weight or the mass. If you have a really really low density but like a really really high mass, it will still float on water because density matters in floating or sinking and not the mass. Because you have because it will just float anyways. It's just gonna be really, really big. This stuff's gonna be really, really big. Now, suggest how the girls could have changed the raft, all right? So that they could put more coins on it before it sank. So how are you able to get it to not sink and put more rafts, basically? Like if you put how can you make it not sink and have it a ton of coins on there? More coins. Remember, they made the raft using a square piece. They made a square raft using a square piece of plastic. So yeah. Anyone? 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 Would anybody like to give me an example of how you can improve the raft?
Mẹ đang ở tầm 7. Tầm 7 đâu chị xin? Xin xin cái nhóm. Tầm 7.
All right, so basically, a simple way to make the raft better is to use it to make it like a bowl or make it look like a ship. The design of a ship is used because it is efficient at making things float. A ship looks like a ship because you need it to float. Okay? So a ship is actually a really, really perfect design, and it took a really long time for people to design a ship. Now, all right, let's continue. So, as you can see here, submarines are able to float or sink. Now, you can see that this is a cut submarine. The hull of the submarine has two layers, and the two layers are big storage spaces, and these are known as ballast tanks. Now, when a submarine is floating, the ballast tanks are filled with air. Now, if you needed to sink, then you get water to go inside. Now, can anybody tell me if you put water into the submarine, why would it sink? Anybody? Why would it sink?
It makes the total mass of the submarine less than the mass of the water it displaces.
Yeah.
So,
Yeah, true. Could you keep explaining, please?
So if it sinks, the mass inside it will less than the water because the water runs inside it.
Yeah, true. Simply when the water goes in, it makes the submarine too more dense than the outside water, so it sinks. All right. Give me a second. All right, yeah. So let's continue. Now, can anybody tell me how can the people inside the submarine breathe if the submarine is submerged? Anyone? Why can people in the submarine breathe if it's submerged? Anyone? How could the people in the submarine breathe if the hole is closed? Because no, if it's submerged. Let me show you. Let me ask. So a normal submarine, you would have air, but if you put down here, where's the air? You can't get the air from outside, so where do you get the air from? Where does the air come from?
From the water? From the water.
Well, let's have another look at the submarines, and can anybody tell me? Let's have another look at the submarines. Is there anything you see that that could help us with getting air? There's something I see. Does anybody else see it too? Anyone. All right. So simply, right? Do you see these vents? Come on, guys. Do we see these vents? If you many things, you never want things to be completely enclosed. So if you see any question that asks on if you see any question that asks on oh, will something float, will something was no it was how would you be able to breathe, make sure to check for vents. There will be vents in a lot of places. All right, vents are really common so that people can breathe. Okay.
Maybe the water could go inside the submarine and the pressure of the Archimedes force that pulls the ship down. The vents open so the water can split out when it floats.
All right. This is technically possible. You could try to use water for you to breathe, but it's really, really hard. First of all, you separating hydrogen away from oxygen atoms is probably one of the hardest things you could do. It's not that easy. And secondly, it costs a lot of money. It's too expensive for you to do that. Yeah. So technically, it is possible. It's just that it's so expensive that you don't really want to spend your money on that.
So in the submarines there is some air tanks.
There are air tanks, yes, for long expeditions when they're in submerged for a really, really, really long time. But usually you would probably need to refill these air tanks, and the best way to refill air tanks is to use air from
Look
outside.
at the you can look at the submarine when it floats.
Yeah,
When it sinks, when it sinks, this part is still underwater. So maybe it has small tubes
yeah,
and
exactly.
oxygen.
That's the entire point. You can see the tubes here. These are the tubes. These are the vents that you get the air from, right?
Yeah, and the air comes in and into the inlet.
Yes, exactly. This is why you will never see a place that's fully ventilated. You will not no, you will never see a place that's fully closed. There will be a slight and tiny opening in every single place that you could think of. There will be a really tiny opening in every single place you work in. All right. So, yeah. Uh, so now circuits. Um, can we continue with the class or yeah. Wait. So,
This this one this one maybe is this.
could you say again? Yes, that is a battery. Correct. Oh no, no, actually, this is we have a small battery and a big battery. We have a small battery and a big battery. So what's the
Okay.
small? So yeah,
Maybe this big battery is this one.
yes,
It's 3 volts. It's three
yes, that is true. Now, what's a small battery?
A small battery is this one up to here.
Yes. Now what about the other set of batteries? The connected ones, the connected ones. Yes.
Connected ones are here.
All right. Now, can anybody do me a switch? A
A
switch.
switch.
An open and a closed switch. There's an example of an open and a
There's
closed
a
switch.
open switch
Yes.
and a closed switch.
Yes, correct. Now, what about a wire? A wire.
Wire. Here's the wire.
Yeah. And what about the light bulb?
Light bulb. The downside is the light bulb.
Yeah, the light, that's a light bulb, by the way. That is a light bulb. All right.
And
And what about the speaker? The speaker. Yes. All right.
this buzzer is here.
Yeah, that's the
Speaker.
buzzer or a speaker, however you want to call it. I usually call it a speaker because it's more familiar. It's familiar to me. Anyways, can anybody list me the components of the circuit? Can any,
These are the components in the circuit. Okay, this one is the buzzer or the
yes, that
speaker.
is the buzzer.
This one is
That's the
a
speaker or buzzer.
large cell 3V battery.
Yes, that is a large 3-volt
3
battery.
volt. And this one is an open switch.
Yeah. Now, will this turn on? Will the
No,
buzzer? Will the speaker make a noise? No.
No.
Why?
no.
Can
The
anybody
switch
explain to
is
me why?
Open
The
switch.
switch is open. It needs to close.
Yes, the switch is open.
Is open. It needs to close. You need to close.
Yes, they need to close. Correct. Now, look at two circuits A and B. Which circuit is a series circuit and which one is a parallel circuit?
This is a series circuit, and this is
a series. And this is the parallel.
Which one's the series? Can any point me to the series?
A.
A is the
A.
series. Why is
Here's
A a
the
series circuit? Why is A a series
series,
circuit?
and this is the parallel.
Can anybody explain to me why A is a series circuit?
Because it connects in
It-
just one line of wire.
Yes,
It-
and what about B? Why is B a parallel circuit?
Because it has wire in parallel shapes that
Mhm.
it's like it's
So,
wire.
which one will shine more brightly, A or B?
A, B.
Why
B.
B? Can anybody tell me?
Because the electrons from the battery can only shine one bulb in the wire. In A, there are 3 bulbs in the wire, so they can shine more brightly.
Mm-hmm. Yeah. Simply put, y'all are
Wood.
correct. And which, sorry, that's one we already answered. So we already done the circuit diagrams. Now, can anybody tell me which circuits are parallel circuits and which circuits are series circuits? This is actually,
Okay, this is parallel. This is parallel. This is series.
well, this is actually kind of a trick question because this is both a parallel and a series circuit, right? You can see that there's a parallel factor and a series factor here. So technically, but if you go with the definition that a series circuit has one loop, then yes, this is a parallel circuit, that's a series. But technically, this is a combination of both. All right.